So, hello everyone and welcome back. Right now, we are back with our session by Tyler Hutcherson, and this session is about under the hood. And actually, right now, we are going to build a Q&A app using Redis. So, welcome, Tyler. Hey, how are you doing?
I'm doing well. Thanks for having me. I'm excited to jump in with you all.
Yeah, so the stage is yours, and
Great.
have a good talk.
Okay, awesome. Thanks for tuning in. Thanks for listening. As you all know, there's this Redis side quest happening with a bunch of these lab events over the next couple weeks. And so the purpose of today, I'm going to dive into an example that we've built that uses Redis and OpenAI to build a question and answer application. So I did a pre-recorded video of something similar earlier, but I'm actually going to go deeper into the weeds and step through some of the code, manipulate some things, and we'll have a good time. Hopefully, we'll all learn something, including myself. And also, the jury's out if I don't have some sort of like live demo mishap, which of course is going to happen because it's live, and that's just what happens. So first things first, I'm actually going to start from again this sort of wonderful tech page. So if you're following along, I'm just going to go to the Redis page. I'm going to go down to our lovely boilerplates that we have. We've put together this simple Q&A application. Some of you guys have seen this. I know it's already gotten a couple stars on here, which is nice. Please keep starring it and forking it. And so with this sort of really simple reference architecture, there's a series of documents that are Wikipedia articles that we're going to use the OpenAI embeddings API to pull them down and store them in Redis. Redis is going to be used as the vector database to then allow us to do semantic search. And so with semantic search, you can ask a question. We can find the documents that we think are relevant to it. We'll be able to use the top documents to construct a prompt and then send that off to OpenAI, the generation and completion endpoint, to answer the question. And so that's kind of how the architecture is going to look like. And on this README, there's a bunch of examples, and I'm actually going to step through here on the right in code how to get this up and running, but obviously we're going to dig deeper than what's just here. So in order so you don't think I'm cheating or something, I'm actually just going to straight up delete the folder that I have here on my machine. It's gone. And so if I'm starting from scratch, I'm going to grab this URL, I'm going to pull it down. So using Git, thanks Git, I'm going to step right into it. Here we go. So just looking around, there's a couple files here. And what I want to be able to do is run this application locally. But what the README doesn't show here is how to actually run this sort of in an interactive mode where I can make changes to either the back end or the front end and have it be represented in my UI. So before I do anything else, I'm just going to open VS Code and we're going to take a look at the project and try to keep this architecture diagram up here, like for reference. Here we go. Okay. So this is the README, that's what's on the left here, but we're going to look at the Docker Compose file. This uses Docker to run and manage these containers. I'm putting some spaces in here just so we can kind of split things apart a little bit. So what we see here is there's two things that this is going to run. This is going to run an application, a Streamlit application. Streamlit's a really great Python framework that just allows you to build simple front-end code with really easy to use API. It's great for demos, and some people might use it for production as well, but definitely great for demos and proving out an idea. So if you're a hackathon team, you don't have a dedicated front-end engineer, you all know Python, look no further. Streamlit's a great place. There's another one called Gradio too, which is great. So that runs a container that runs the Streamlit app, and I'll show you how that works in a second. This is Redis. This is our Redis stack server. The reason we need Redis stack is because Redis stack includes the modules that we're going to enable on Redis in order to do things like search. So for those of you that are not familiar, there is a page here on modules. These are all extensions to the Redis database. So the one we're going to be using is Redis search. There's also Redis JSON, Redis graph, Bloom, you name it. There's a bunch of things in here. And Using Redis Stack Server, the Docker container, has that module pre-built into it. So we don't have to do any extra sort of tweaking or custom things for this deployment. So this is the simple sort of Docker set of settings I'm going to use. It's going to pull that image, expose some ports. This is the classic Redis port for those of you that know Redis. We've got an environment file we need to make, so we're going to look at that. And then we're also going to create a volume. And so some of you may know, some of you may not know, but using a volume here will allow us to sort of persist the data between sessions so that when we work with Redis, we don't have to like recreate and re-add all the data every single time to Redis when we spin up the application. And then just for good measure, we're going to add a health check. You don't really need to do this. I like to do this just to show that I think I know what I'm talking about, but it's a good thing if you want to make sure Redis is live all the time. And so that's that. This is Docker Compose. So this is the stack we're going to try to run. And so let's see, make sure my terminal works. Increase the size because I'm sure you all are squinting. So I'm going to show you how to run this just right now, point blank, without making any changes. And so that's just what's on the README. We're going to copy the environment template file into a new env file, which is the first step here on the left. And that new env file has a bunch of things already in here. We can keep pretty much everything the same except for the OpenAI key. All of you doing this hackathon have probably created one, but if you haven't, the way it works is you go to platform.openai.com, log in. Of course, I have my little Redis account here. I'm going to go to a few API keys, and I'm just going to create a new secret key. I'm going to copy that, put it here. That's how easy this is, folks. Like working with OpenAI is great because you can just come in here. They hide it from your view so you can't like try to steal it or whatever, and you can revoke them pretty easily. I'm going to revoke this one after we do this demo. But that's it. Grab your OpenAI API key. That's how you connect it all together. So now that we have our env file, we've got our API key. Next thing is just simply running docker compose up. And on some systems, it might be docker dash compose. So if your system freaks out about docker compose up, try the other one. We're going to run that. And let's try to make this a little bit bigger so you can see. Okay, great. So the first set of logs here is for Redis. You can see Redis OpenAI Q&A, that's the name of the project. The container name is Redis. And this is all the normal looking Redis startup logs. So we have, you can see a bunch of the modules that are in here that I mentioned. That's why we're using Redis Stack. And the other application is Streamlit. So it's also currently running. Everything looks good there. I'm going to try to navigate to it. And there it is. It popped right up. So this is the application at its core. It's very simple. I even added some more explanations of how it works here once you have it running. So if you want to kind of in context while you're playing with it, you can see how is this all coming together. So just as a test to make sure we are up and running, I'm going to ask like, let's see, which country won the most gold medals in 2020? So now OpenAI, Redis are working together. You can see it tells us the United States won the most gold medals in 2020 with 39. That's pretty good. And you can see this is the set of context. These are the documents that were searched for and returned from Redis using vector search. Using vector similarity search, these documents came back as, hey, these are the most relevant documents we think you're going to need to answer the question. And then our code, our backend, which we'll step through, takes a look at that and parses it, puts it in the right format, and sends it off to OpenAI to have the question answered. And then that's how this response comes in. So again, this is the demo. You might have already seen this. You might have already tried it yourself. But I'm going to shut this all down because what I want to do is show you how I like to sometimes work in this setting. I'm actually going to comment out Streamlit section completely. So you'll notice now the Docker Compose file just has Redis in here, which is great because we've been able to set up all these other settings here and get the Redis container running no problem. So yeah, comment out Streamlit. And let's take a look at the Docker file for Streamlit. This is what's actually running for the Streamlit application. You can see the command, the entry point for the app is just Streamlit run app.py. And these arguments are probably not necessary for this demo. So what this is going to do for us is give us the ability to run the database with Docker and run Streamlit outside of Docker, and we can make changes and the application will edit in real time. So in order to do that though, I need to change my Redis host. And this is just a networking thing. So when you run both your containers inside of Docker Compose, it creates a network layer and they can talk to each other in the same network. If you're running the Streamlit app or any backend application for that matter, whether it's a fast API or if it's anything, you can simply change the host so that it's just pointing to localhost because Docker is doing all the routing to make this work for us. So that's the one change I needed to make there. Localhost is your Redis host now. All I'm going to do is Docker Compose up again, so this should be familiar, but I'm going to put it in the background. I'm going to detach it and daemonize it so that Redis is running in this container in this stack here, and I don't have to like sit here and watch it. I can continue to use my terminal for other things. Okay, so you can see created the container, started the container. To confirm that, I can type docker ps, and this is going to allow me to see the containers that are currently running. And you should see here, Redis stack server latest entry point created 9 seconds ago. It's healthy. That's great. And now we should be good to go. So I'm going to go into the application folder. And inside here, you'll see app.py. You'll see a couple different things. App.py is our main application we want to look at. So I'm going to spin this up in a second. But first wanted to just take a look at this code. So you can see Streamlit. We're using Streamlit here. A couple other sort of helper things. And then the other one is our own custom module that we built, which we're going to unpack, called Q&A. Q&A has a function called answer question with context. And we added like doc strings and stuff, so it should be easy to understand here. But essentially with Streamlit, there's a session state. With the session state, this is just like kind of any front-end code. You'll want to utilize this for sharing information or sharing variables or sharing data across your front-end application. And so, yeah, got it. Thanks for that. Yeah, let's see. This is a little bit helpful, more helpful. Is that better? Okay, great. So this is our Streamlit app. As I mentioned, we want to set up the default of all these things just to be empty. Our default question, answer, prompt is just going to be a clear state. And that way, when you look at this sort of bar that you can type in, it just starts out blank. And they don't have to be blank. Like you can change that. I just wanted it to be a clear state. And then the next thing we're going to do is we're going to set up a couple columns for our view. At the very top, we're going to put that image, the one you guys saw where it's like Redis OpenAI. That's just going to be the top banner on the page, is the image. Then we're going to break it out into these columns where we have some text that's shown, and we have an expander that I don't really use yet. That allows you to set different kinds of settings like the temperature, the number of tokens, and the response. Then this is the big one, is this is where the text input field comes into play, because we're going to have a labeled field that says, ask thoughtful questions about the 2020 Summer Olympics. This is going to require user input. So we're going to take that question that users are typing into the bar, and we're going to check. If the question isn't empty, which is this one right here, and if the question doesn't equal the current question that we have in our state, then that means the question has changed, right? It's set to something and it's no longer what it was in our initial state. So we're going to update the state with our current question. And then this is where we utilize the answer question with context function. So we create a little spinner that you probably saw when I demoed it, so that it's just a little bit of a better UX. It shows you, hey, Redis, OpenAI, working together to answer your question. And then we take the results of the answer question with context function and assign that to the prompt and to the response. And then we use those fields down here to print out the results. We print out the initial question, and then we also look at the response that we got back from OpenAI. And if they choose, you can open up the sort of expander and see what the context was for the prompt. And that's what this piece is here. And then underneath this is all just like basic markdown, writing out some of this content for instructions, and then lastly, the architecture diagram below. So that's the app. And to run a Streamlit app, once you're in the app folder, you're just going to do streamlit run.py. This may fail because of my Python environment, which I forgot to mention. Oh, nope. Okay, we're good. Yep, and it doesn't like that I don't have the OpenAI API key. Good call. So because I'm not running this with Docker, you have to manually set these environment variables. And so I'm just going to do this right here. Export OpenAI API key. And that is this one right here. Boom. And then I think the other thing I need to do is the Redis host too. I'm going to export these environment variables. There's definitely a better way to do this. Like you can write some function to take your environment file and basically just export it to your current environment. Okay, so once you get your environment variable set, you should be able to run the Streamlit app now. Back to that command, Streamlit run app. Great. Okay, so this looks just like it did when we were running it through Docker. The thing is now you can come to the far side over here and you can do things like you run it, you can hit some different settings over here like recording a screencast. That's really interesting. You clear your cache, developer options. But now let's try it. Let's see what happens if I make a change. So back in my code, close out Docker, let's look at app. Let's say I want to name this something different, just so you can kind of see this reload. I'm going to say interactive Q&A application. So notice up here at the top, it says source file changed. I can say rerun, or I can just say always rerun. For this case, I'm going to hit always rerun. So you see down here, reloaded the app and it's updated the text. So this is great because I can basically edit like the front end and the back end at the same time. It's all just Python. So if you want to experiment with different aspects of this UI, this is the best way to get it set up so that you can just do this in real time. Once you finish it and it works, obviously you can commit your code, you can rebuild with the Docker file here, and then you can run it back in your stack. That's one way to do it. And now is a good time for us to look at the actual Q&A piece of this, because I wanted to make sure we had enough time to go through the sort of meat and potatoes of what's happening in this diagram. So I'm going to actually start with the database file. So you'll see two modules here, db.py and models.py. db.py is everything related to Redis, and models.py is everything related to OpenAI. And then they come together inside of like this the base of the Q&A module here, and I'll kind of go through that last. We'll start at the db.py. So with working with Redis, you have to define an index name, and you have to define a prefix. The prefix is the first part of the key for data that's going to be stored in Redis. And that data is going to be associated to a particular search index, in this case, embedding index. I've created a bunch of different constants here, like how many vectors, the dimensionality of the vectors. A lot of this stuff might be environment variables, or it could be things you define more dynamically. Obviously, for this demo, it's just simple to have constants here. But generally speaking, before you can do any searching in Redis, you have to define and create an index. So this index, you can define a schema by saying, these are the different fields in my data. So imagine you have like a JSON file or you have a CSV. You have this like structured data that you want to assign the columns to how they're going to fit into Redis. Now, you typically don't have to do this for normal Redis data. Redis has a lot of flexible data types that you can just natively write with. The thing here is that we're using Redis search, and with Redis search, we want to tell it, hey, this is a text field, expose different search qualities to it. Same thing with numeric fields. We want to be able to potentially filter by numeric ranges. And then, of course, the one we're all probably interested in for this hackathon and others is the vector field. So we want to define an index type here. This is a flat vector index, and then a bunch of other qualities about the vector. So what type of data is it, the dimensionality, some other metrics here that, like for example, we're going to use cosine similarity for the vector search. The initial cap is just like a ballpark estimate of how large you think this index might be, so it can do proper allocation inside of Redis. Not super mission critical to get that exact. Once you have all these things, you pass it right through the create index function. And the way Redis Pi works is you can call out the FT operator, which will return, you can see here, will return our search client, and you pass in the index name. So I want to say Redis connection, connect to my search client for this particular index and create an index with this definition, these fields, this prefix. This is kind of how you get everything set up. The other really important function I want to look at is the actual search. So once you create your index and you load your documents, all this code is in db.py. Everything related to Redis is here. You actually want to perform the search, and this is where you do vector similarity search. And our base query is just saying, search for all data in Redis associated with this index using a k and n style query for the top, say 5, k is an integer, over the embedding field, which is the field we created. And this is a parameter, so we're gonna use that to assign our vector into it, and we'll use like replacement, and then return the result as a vector score. So you define that query just in line here, pass in the base query string. We want to sort the results by vector score. We want a page to get 0 through k, again top k, and we want to return specific fields. And then this is something that you kind of have to do right now for using vector search. There's a break in the API a couple years ago, and so you have to add dialect too. And then you can pass through, in the param dict, you can basically give it the query vector that was created by OpenAI when you pass through the search string. And then last but not least, you actually perform the search. So it all comes together in this single function call here, FT, pass in the index name, and then you can perform the search. You get the results. We made this handy little sort of processing function, process doc, that kind of converts it from the data structure that it's in to the one that we need for our application, which is just a dictionary. And that you can see returns a list of those. So search Redis is just performing the initial stage. Let me go back to my architecture diagram. Search Redis is performing this part of the process, find relevant documents. The next piece of that, so you can see search semantic Redis. Search semantic Redis takes the search query from the user, gets the embedding from OpenAI, which we saw in that diagram there, and then calls our function we just took a look at, which was search Redis. That is used inside our big function, answer question with context, where we want to basically take, let me find it, here it is. We want to get the most relevant document sections that are returned from the database, and we're going to iterate through those results and build up a sort of query string, a larger query string that's going to contain all of the text from the top results from Redis. And we're going to pass those in through our OpenAI model that we're going to talk to again with an API. So this function, construct prompt, is basically taking all the results that we got back from Redis, and you can step through this. It's very simple code to read, and essentially creates a larger string, the full prompt string. You can see it returns, passed to the generative language model. So if you remember back in our app, this function, answer question with context, that was the one that kind of gets triggered when you do a search. And that's this function right here. It simply answers the question. You put in the question, it does the prompt construction where it queries Redis, gives you the prompt at the end that we want to use. You can optionally print out the prompt. This is great for debugging. And then last but not least, we call get completion, which this uses OpenAI's completion endpoint to try to answer the question that you've sent it using all the information from Redis. So I know we're kind of nearing the end of my particular slot today. Have no fear. I was moving really fast. There's a lot to cover here, obviously in detail. I know that tomorrow we're going to be doing another session, so get excited for that. What's likely going to happen tomorrow is I'm going to kind of pick back up around here, do an accelerated version of what we already got to, go a little bit faster, a little bit deeper through the rest of it. So I want to make sure we kind of cover that, and then I might show some stuff live, sort of typing in commands in a Jupyter notebook that we can see how to interact with Redis, kind of regardless of how you might use it, because there's a lot of ways you can use Redis. Vector search is one of them. And I want to make sure we have a little bit of time for questions about this application and how to use Redis here. No, we don't have a crazy amount of time. So with that said, Liza or Lisa, thank you for having me. I know it's such a short time and I crammed a lot in.
Yeah, that was pretty intense. Thank you so much, Tyler. I think, yeah, I'm not a technical person at all in general, and for me it was like, wow, okay. But anyway, we will have this session saved. So if you want to recap on some details, you just can go to our YouTube channel and watch saved live stream. Also, we will share it across our social media, or you can, be always updated in Redis channel on our LabLabAI Discord. And thank you so much again, Tyler. And yeah, looking forward for tomorrow's session. It's going to be also intense, as I could suppose, right? Uh,
Yeah.
and yeah, I'm just checking the questions if we do have any in the chat. So our participant asked, how would we actually get the embedding to Redis? If it means success, right?
Yeah. So if make sure I understand the question correctly, how do we get the embeddings into Redis after they've been created? Is that the question?
Yeah, how would you get the embedding to Redis?
Yeah, so inside that application, there's a folder called app, and then there's a folder called Q&A, and then there's a file called db.py. And we were looking a little bit at that during the call. I didn't go over specifically how you like index or load the documents, but if you look in there, there's two key functions to look at. One is index documents and one is load documents. Load documents pulls from like a hosted, in this case, it's like a hosted data set that has already been fully embedded using OpenAI. And then those documents get written to Redis for the search index that was created. And those would be the two functions to look at in terms of code, like how to do the writing. It's actually like a Redis hset command, which like writes a hash to Redis. And in terms of the embedding creation, if you look in models.py, there should be a function called get embedding. And that just is a wrapper around the API call to reach out to OpenAI. So yeah, those would be the two places to look.
Okay, cool. And as a reminder, I want to just said if you need access to Redis because you still have time to implement it into your application and participate in our side quest, also not just OpenAI Hackathon, you can always tag our mentors or developers from LabLabAI site, and we will help you to get access to Redis, to get some credits, and not only if you need any uh, kind of guide or help with that, just really, as Tyler also mentioned, go to Redis and go to Redis channel and ask your questions there. Yeah, and also like an information for those who maybe didn't get it yet, you can also implement Redis to your Ready application, and then you can participate just in Redis sidecast. So yeah, it will be really nice to improve your application using Redis. And I guess we have one more question.
Sure.
Okay. Is there a way to embed my data without using open API? Not mine, but someone's.
Yeah, absolutely. There are actually a lot of different embedding providers out there. These are folks that may host some of these models for you to hit with an API potentially. So OpenAI is one of them, Cohere is another. I know there's some hackathons that have been going on with both, and we'll continue to. And there's a bunch of others like this. If you want to create embeddings that don't use one of those hosted APIs, but actually use a model that you're managing, if you're comfortable with using an open source model, one that's just been developed and submitted by the community, the best place that I would point you to is probably the Hugging Face sentence transformers library. That library is pretty popular. Was popular well before OpenAI and Cohere came to the scene. And there, a lot of those models are based off of the BERT model, and so there's a big, large, there's a machine learning model that can work with natural language that has been adapted for a couple different use cases. That the sentence transformers library is all open source Python. You can install it. So look at Hugging Face sentence transformers. That's one way to kind of host it yourself. Obviously, if you want to host your own PyTorch or TensorFlow model from scratch, uh, that's a lot more intensive, but it's definitely possible, and we can talk about that. So definitely ping me if you want to any help there.
Okay, thanks for the answer. And we have one more question. Yeah, big
Sure.
thank you from the participant. And yeah, on which stage of the product we can actually implement Redis to applications?
Stage of the product. So are you, just to clarify, are they talking about which stage of their product, or like the product that they're iterating and building on with their team? If that's
Yeah,
the case,
I guess we can go in two directions. So probably you can implement it just from the beginning, from the scratch as you start building, and actually you can implement it on the later stages. Is it like possible?
yeah. So because Redis is a very flexible database, like we've been really broadcasting our vector similarity, vector search capabilities. That's what a lot of the tutorials and examples and things on the LabLab Tech page highlight. However, Redis's traditional heritage is in caching. And so there are a lot of use cases that you can just simply speed up your application front end or back end by implementing Redis later on, potentially as a read-only layer above your primary database, so that if you need to access certain data structures faster, you can just call Redis directly. And the latency of those requests are going to be in the order of single digit milliseconds, depending on how you deploy it. And that might speed up, it will speed up your application in a lot of ways. And that's a way you can add Redis kind of capabilities later on. And it's not leveraging vector search necessarily. If you want to start with Redis more as like a first party participant in your stack, then looking at it as a vector database or as an ML feature storage or feature store engine is a good starting point. Um, yeah, so that's a little bit there. I think it's flexible enough where you can use it kind of wherever you need it. I know that's vague, but hopefully that gives you a little bit more commentary.
Okay. Thanks for the answer. Yeah, I guess it's pretty clear for all the participants that if you need any help with Redis, you can always go to Redis channel. If you need any help in general, just tag our mentors and someone will get back to you with technical or non-technical help. Yeah, as we're also helping as a marketing team, we can answer all your business questions. Yeah, sometimes we can be lucky to catch our founders also. So yeah, just make sure you're always live on LabLabI Discord. And thank you again, Tyler. Will not take much
Yeah.
more of your time. Thank you again for answering questions and looking forward to see you tomorrow.
Yep. Good to see you guys. Take care.